Hi everybody, this is lecture 6 from week 4 of CS 1030. And this is basically, this lecture segment builds directly on the previous one. We're going to continue talking about abstraction using functions in Scratch, and also talk a little bit about abstraction using functions in general, that is to say outside of Scratch. So let's look at an example of a custom block that you might use in Scratch. So here's a block that we've called safe move. So it's a custom block, and it takes a parameter called steps to say how far to move safely. And so what does what does it mean to move safely? Well, what we mean by that is we move the sprite by the parameter steps, number of steps in its current direction. And now if we're touching a wall, if the sprite is touching black, then move it backwards that same number of steps. And if you think about how we would move a sprite backwards, one thing we could do is turn it 180 degrees and then move, and then turn it 180 degrees again so that the sprite ended up pointing in the same direction. But it's probably simpler just to move it in the current direction a negative number of steps. So what you can see is this guarantees that if the move would have ended up putting the sprite so that it partially overlaps with the border, then it's gonna end up getting moved back to where it was before. So the safe move block is just a sort of a way to abstract out the functionality of moving the sprite, unless doing so would cause the sprite to be in a wall. So let's look at how we can use that to clean up our code. So you want to be able to move your sprite in any direction. So you're going to have event handlers for up arrow, down arrow, left arrow, and right arrow. And each of those is going to do something a little bit different. Up is going to point the sprite at 0 degrees, and left is going to point the sprite at -90 degrees, so directly to the left. And so we can't use the same code for all 4 of these events, but the safe move is common across all of them. So what we can do is, as shown here, point when each of the arrow keys is pressed, point the sprite in the correct direction, and then invoke the safe move functionality. And the really nice thing is, once we've written that safe move code and we've debugged it and we're happy with it, we can just use it wherever we want. And so this is the real power provided by abstraction using functions, which is that once we get something right, we can basically forget about how it works and start using it. And this is, really incredibly important. Okay, so let's talk about something different. So mostly so far, we've been looking at doing something kind of visible using a custom block. But what if we wanted to just compute? So we want to maybe let's consider, for example, we have a custom block and it computes the nth prime number. So this doesn't have any effect on any sprite. All it does is it takes a number n and returns the nth prime, so whatever that is. So getting the n to the nth prime custom block is easy. We can do that through a numeric parameter. So we can have the custom block accept a parameter, and when we call it, we can say which prime number we want. But how do we get the information out? How do we get the nth prime, the actual prime number, how do we get that back out to the calling code? And it turns out that this is inconvenient in Scratch. Scratch doesn't have a specific mechanism for returning a computed result from a custom block. And this is a bummer because almost every real programming language provides this kind of a thing. So we can write a computation, for example, a sine or cosine or whatever mathematical function, so we can have it return something to the calling code, and Scratch doesn't make that convenient. So let's look at how we would actually do that in practice. So what we do is we pass inputs to the custom block through parameters, and we store the output in some sort of a variable. So we would basically just store the we just define a global variable in a state variable, and the custom block puts the result there, and then the calling code has to know what variable it was put into. So if we look at the example on the slide here, we're calling a custom block called join names. We're passing it first name and last name. The custom block is going to put them together. So it's going to set full name to the join of first and last names. And then that's how the result, that is to say the join names, are being returned to the calling code. The calling code has to know that when it calls join names, it's going to put the result in full name. So that's not necessarily a great way to do this, but it's basically the best that Scratch gives us. So if you want to do this kind of a thing in your Scratch code, you basically just have to do this. And again, a more powerful programming language, a programming language designed for actually getting work done instead of teaching, would support a better way to do this. Okay, so what's going on here? So a custom scratch block is basically you're defining a function. So a function is a parameterized piece of code that can be called from other places in a program. And parameterized just means it takes parameters. They could be numbers, they could be strings, they could be something else. It just means we can send information through the parameters to a piece of code that we've written. It can compute using those using those parameters, and then it can do something or return a result. So that sounds simple, and it is simple, but it's incredibly powerful. So one thing I'd like to caution you about, and I mentioned this already in a different lecture, but in computer science, for some reason, we like to have lots of different words for the same concept. And I don't know why we do this, and it's not good, but we do it. So you're gonna have to deal with it. So a function is one thing that we call the thing that a scratch block is an example of. Another thing we call them is a procedure or a subroutine. And by and large, you can use function, procedure, and subroutine interchangeably. By and large, they're more or less all mean the same thing. But some people will make the distinction that a function would compute a value and return it, whereas a procedure or a subroutine would execute some sort of actions that affects the world, like, for example, moving a sprite or something. So that's a sort of a subtlety. You probably don't have to worry about that too much. Anyway, I just want you to know that there's different words for the same thing here. You'll see them used, and you should just know that they all map to the same underlying concept. Okay, so to kind of try to bring this all together a little bit, abstraction using functions is an absolutely key skill. Computer programming as we know it is really just not possible without being able to break up code into functions. It's almost the most basic tool in the toolkit that we have for writing programs. And you really just have to learn to do this. It's almost the single most important thing you'll learn during your time here as a computer science student. So one thing you might have noticed is that I've told you how important this is, but I haven't really told you how to do it. I haven't told you how you should know when to break code up into multiple functions. And the reason I haven't told you is there's not necessarily a single right answer here. It's a matter of taste. It's a matter of kind of experience and getting used to figuring out when that would improve the quality of the code to break it into multiple functions as opposed to leaving it as a single large function. And this is the kind of thing where you could find substantial disagreement even among experienced programmers. So the things I'm telling you here are my ideas. They're not necessarily agreed upon by everybody. But what I would say is, if you're writing a function, if you're writing up some code, so for example, some code solving some problem that I've given you, and it starts to get too difficult and too complicated, that is a sign that you need to break it into functions. So what you should do is start looking for some piece of functionality that can be extracted out into a function, and then there's two ways you can do it. One thing you can do is just go write that function immediately and then go back and start using it. But the other thing you can do is you can kind of pretend that the function exists. You can write code, and this code isn't going to work because the function doesn't exist, but you can write code that has a hole in it where you're going to put this, this custom block. And then once you get that code working and you're pretty sure that it sort of looks like it's doing the right thing, now you go and write the function. Now you go and write the custom block. So either one of those works. Neither of them is better uniformly than the other. It just sort of comes down to how you want to do it. But in any case, the idea is when your job as a programmer starts becoming too complicated and too difficult, that's often your program telling you that it needs to be broken into functions. And it's a little bit of a bummer to hear this, I believe, because so the deal is you're already sort of at the limits. Once your code is becoming really complicated, you're sort of by definition at the limits of your mental capacity to understand everything that's going on. And now I've told you to do something else that's also hard, which is to figure out how to break it into functions. And you're already sort of stretched to your limit, and now you're going to try to do something else difficult. And I'm sorry, that's just the way it is. There's no real answer for how to get around that. But what I can tell you, though, confidently, is that after you've done this job a lot of times, after you've spent some time breaking code into functions, it becomes easy, it becomes second nature, it becomes sort of habit that you just start to learn how to see the code break into functions. And again, that is one of these incredibly important things that we're spending 4 years trying to teach you. So another key you could use to tell you that a function needs to be broken up into multiple functions that call each other is it just doesn't fit on a page of code anymore, or it doesn't fit on a screen anymore. If you can't see it on a screen at once and you have to scroll around to sort of look at the different parts of your code, well, probably it's too complicated. It's probably too long. It should probably be split up. So that's not sort of a hard and fast rule at all. And again, other people might disagree with me, but this is something that I kind of feel would be a reasonable guideline. So if you start getting confused about what your code's doing, or if you can no longer fit it onto the screen all at once, this is your code sort of starting to tell you that it wants to be structured differently. And very likely the way you should structure it differently is by breaking it into functions.